Hello again and welcome back to our series of Wildgen tutorials. Today we're going to be pulsating an LED, and basically we'll be using pulse width modulation. So make sure that the LED that you have connected is using one of the pins that has a tilde right next to it, because that means that that's a PWM pin. Now, what does pulse width modulation mean? I've got a graph here that might be able to help you with this. Basically, what we're going to be sending to that LED is a signal that goes from 0 to 255, which means that for 0, for instance, the value that it gets is always 0, and for 255 it means that the value of the signal that it gets is always 1. In between these two values, you can see how at 25%, it gets 1 for 25% of the time, and then 0, and then it starts over again, so it's like a cycle. For 50%, it's half and half, so it starts with 1, and then after half the amount of time it goes back to 0, and then 75% it stays for 75% of the time at 1, and then it switches back to 0. Basically, this happens so fast that the LED actually looks as if it's displaying a percentage of the amount of maximum light that it can represent. That's only because the eye is only so quick to adjust to the changes in intensity, in light intensity. Okay, so how is this exactly going to work? We're going to be using the same setup as last time. Again, just make sure that the LED is connected. I have it on pin 3, but it can be on 5, 6, 9, 10, 11 as well. You then connect the potentiometer to 3 of these pins. One of them will be going to ground, one of them will be going to 5 volts, and one of them will be going to an analog input. Now, because I need to use the ground on the potentiometer as well, I'm just going to move the ground from the resistor over here and then connect another ground on this row. Basically, everything that you connect to the bottom row will be connected to the ground. Okay, so I also need to connect the potentiometer to the ground. Okay, then we need to connect the potentiometer's last pin, the third pin, to the 5 volts here. And of course, the middle pin has to be in one of these 3 analog inputs. I'm just going to connect it on A0. First, we're going to be checking how the LED changes light intensity with the values that we give it, and then we're going to be connecting the potentiometer. We're going to read the value from that every 100 milliseconds or so. Okay, so let's get started. Back in my applications, I'm just going to create a new one, Pulsating LED. Make sure it's a visual programming project, and then click Next and Submit. Okay, I find its name here. I click it. We don't need to print anything on the screen for now. Now go under Pin Access and you're going to see this analog write block. We're going to be using the same pin every time, and we're going to give it a value that's different every time, so just delete these. Go to the Program and Math, Numbers and Math here. Basically, we're going to be writing on pin 3. And the values we're going to give it are going to be 0 for starters, and then we're going to wait a bit, so we need to add delay. Maybe 1 second is a bit too much. How about we change it to 500 milliseconds? So that's half a second. Okay, we're going to be giving it a value between 1 and 255, let's say 107, and then add another delay. And then give it the top value that the LED can receive, which is 255. Okay, and let's just put this in a loop. Repeat while true. Okay. Make sure you have the board connected to the internet and also connect the power cable. We forgot this tiny little detail, the last delay here. Okay, now that my board is online, just gonna click its name in order to deploy the application on it. And as you can see, the LED switches through 3 power settings. What's going to happen then is we're going to take that signal and map it to the signal that goes to the LED that says it's from 0 to 255. Okay? We're also going to be sending this signal to a gauge graph that we're going to use in order to monitor that everything is behaving correctly. Okay, so we don't need all of these programming blocks here. We're going to be setting an input, so the value of this will be the analog data. Okay, so analog read from pin 0, as I have it connected on A0. Okay, so you don't need to enter the A as well, just make sure it says pin 0. And we're going to be adding a variable here, and we're going to call it input. So we're setting input to the analog read, so basically the data that we get from A0. And then we're also going to be sending a signal here, so we have to go to signals and send the signal. The signal is going to be called gauge, and its value will be our new variable input. So go back to variables and drag the input block here. Okay, just in order to monitor how everything is going, we're also going to be adding this in the dashboard. So say add a solid gauge, and this is going to be the gauge signal. Its lowest value will be actually 0, and then say 400 for the mids, 800 for the highs, and then the maximum value is of course 1023. The colors seem to be okay. Okay, now go back to the main here, and what we're going to do is we're going to analog write on pin 3 a value that we get from this input. But as we want to change the value, we're going to have to go here to numbers and math and map the value here. Delete this block. So the value that we add is going to be the same one that we got from the analog input. Okay, so map the value input. From the lowest value 0, it's going to go also to 0, and then the highest value is 1023. The highest value is correctly set at 255. I'm going to decrease the delay here, because if we only do it every half a second, it's going to be too slow. Okay, so let's see how that's behaving now. Okay, so that's on right now, on full blast. Now I'm decreasing it. It's on 400, 200, 100, and 0. And then let's increase it again. As you can see, the intensity of the light in the LED changes with the amount of rotation that the potentiometer has. And now it's on full blast. Okay, thank you for watching. I hope we've all learned a couple of things about pulse width modulation and how we can use that to pulsate an LED.